this video, we are going to discuss what is X-ray diffraction. For the objectives to understand the basics of X-ray diffraction theory in terms of X-rays, diffraction, and Bragg's law, to observe one method of evaluating atomic crystalline structure by using X-ray diffraction to understand the use of Bragg's law and its relation to crystal structure. Introduction. Few scientific breakthroughs have an immediate impact as Wilhelm Conrad Roentgen's discovery of X-rays, a momentous event that instantly revolutionized the field of physics and medicine. Around the same time, crystallographers were becoming convinced of the space lattice-like construction of crystals, a topic that von Leeuwen discussed with his friend Paul Peter Ewald. Von Leeuwen's experiment presented evidence for the wave nature of X-rays and the space lattice of crystals at the same time as the diffraction spots were caused by X-rays impinging on a regular array of scatters, in this case the repeating arrangement of atoms within the crystal. So what does really mean by X-ray diffraction? X-ray diffraction is a powerful non-destructive technique for characterizing crystalline materials. It provides information on structure, spaces, preferred crystal orientations, texture, and other structural parameters such as average grain size, crystallinity, strain, and crystal defects. Performing XRD analysis. This test method is performed by directing an X-ray beam at a sample and measuring the scattered intensity as a function of outgoing direction. Once the beam is separated, the scattered, also called diffraction pattern, indicates the sample crystalline structure. The condition for maximum intensity contained in Bragg's law allow us to calculate details about the crystal structure, or if the crystal structure is known, to determine the wavelength of the X-rays incident upon the crystal. And now we're going to define Bragg's law and its relation to crystal structure. Bragg's law was introduced by Sir W. Bragg and his son Lawrence Bragg. The law states that when the X-ray is incident into a crystal surface, its angle of incidence theta will reflect back with same angle of scattering theta. When the path difference d is equal to a whole number n of wavelength, a constructive interference will occur. So now we're going to discuss the Bragg equation and its relation to X-ray diffraction. So Bragg's law has an equation of n reverse y is equal to 2d sine theta, where reverse y is the wavelength of the X-ray, d is the spacing of the crystal layers or the path difference, theta is the incident angle, and n is the integer. This diagram shows the X-ray diffraction. When electromagnetic waves strike a lattice of atoms, they can reflect. See the diagram? Those reflecting of a subsequent layer must cover an extra path difference of 2d sine theta, and one has constructive interference. Good day everyone, I am Morena Dueñas and we're going to try solving a problem about X-ray diffraction. With the use of Bragg's law, we are trying to solve this problem. X-rays with wavelength of 125 picometer was used to study a crystal which produced a reflection of an angle 17.4 degrees. Assuming first-order diffraction, what is the distance between planes of atoms? So first thing we need to do is to write the given, which is theta is equal to 17.4 and the wavelength is 125 picometer, and the n or the order of diffraction is 1. So now we are trying to show a diagram for this problem. Which is 17.4 for the theta, both side, and we are looking for the distance between planes of atoms. D is, And now we are using the Bragg's equation, which is 2D sin theta is equal to n multiplied by wavelength. So now, let's derive the equation since we are looking for the distance. So d is equal to n multiplied by wavelength over 2 sin theta. Substituting, for the n is 1, the order of diffraction, multiplied by 125, the wavelength, over 2 sine theta, which is 17.4 degrees. So now we're trying to calculate this. So the answer is 209 picometer. So the distance between planes of atoms is 209 picometer.
So thank you for watching. Hope you learned.